Okay, I guess we are started. I am in La La Land over here, so let me bring up my presentation so we can both be on the same page. Voila. Welcome. Thank you guys for coming. I'm Tara Walker. I'm an AWS technical evangelist, which just means a software engineer that also talks to people. And today we're going to be talking about IoT and mobile connected cloud. Now, here's a caveat with this. My coworker literally banished all the devices I had on my back and checked them. So I will be still doing IoT demos, and you guys are actually going to help me because this is about mobile and IoT. So we're actually going to control some devices, and you're going to help me do it. Since I was banished from all the things that I had on the table that you guys probably couldn't see, given that I don't have my dot cam. All right. With that, we're going to talk about mobile and IoT. We're also going to talk about the good, bad, and ugly on it. This talk is really hard to do in 15 minutes because I have a lot of code to show and a lot of demos to do. So we're going to try to muddle through it. If at any time, you guys are pretty far, but you can throw some at me if I go too fast. All right, let's get started. So you guys probably already know what this IoT thing is, right? It is this complex definition, right? The interworking of physical devices, connected, all that's great. That's a lot to say. And I believe in the whole KISS method, keep it simple, stupid. So instead of saying that mouthful, really, let's just keep it simple. It is a network of devices and things. It's going to be made smart by microcontrollers, sensors, and actuators. It's going to be connected to the internet in some type of way, whether that be intermittent, whether that's consistent, or whether that's at the edge. And then we're going to exchange data, which we call telemetry data, back and forth, and it's going to interact with us as humans and the physical world. That's pretty much what IoT does. Now, the current trends you probably have heard so much, IoT, but then you hear AI, which I love both of them. But what I don't think most people realize is when you're thinking about a solution with IoT and with artificial intelligence, what connects both of those are typically mobile. You guys are usually connecting with these great IoT devices or just AI solutions via your mobile phone. And so as developers, we need to really think of this as a holistic solution of how to interact with this world. Because of this, we need to make sure we're building things based upon these data-driven decisions you guys are making. You have these data, that the sensors and these analytics, and you can make these data decisions as a company as well as a consumer almost dynamically. But of course, with everything that's good, there is somewhat of a catch. Because with IoT, there are challenges. There are 1 trillion devices out there. There's the Pi, there's the Spark, there's the Android things is coming out where you can do various things with different little bots. Actually, the device is called little bots. The Edison is going away or has gone away, but then now they have the IoT gateway. And there are millions of producers and devices. So think about that now, that challenge at scale just with IoT devices. And then there's trillions of different phones. If we think about the Android platform itself, there are millions of them. So you have to deal with not only the hardware aspects, but then there's challenges software. And then when you start talking about distributed software, those challenges become huge at scale. What if do I have a network connection? Do I not have a network connection? How do I manage 1 million devices to 1 billion devices versus just a few I have in my home? And you can really start to see the diminishing value of data if, one, it's not recent, because recent data is highly valuable. As it starts to get older, it diminishes. So we got to really think about the timing of all this. Old plus recent, if we're talking about trends, is then more valuable. But again, there are some reasons why this is not the easiest thing to do. So I want to talk about building mobile and IoT solutions, but I would be remiss if I didn't talk about the good, the bad, and the ugly, which I'm sure we all have experienced. The first thing is the ugly. Let's just cut to the chase. Rooting firmware of various different devices consistently is a pain. The various devices I literally had in my bag that my coworker just banned from me that's sitting right now in checked in bags. I had 10 different devices to show you guys. And it was like, there's nowhere you're going to put those in there. And I had to root every one of those. And some of those flashes are not easy. And depending on what version of the device, it can be terrible. And then what about security? So I don't know if you watched Mr. Robot, but if you remember that Data Mountain was hacked by an IoT device. So you need to make sure that your device is secure. And how we do that prospectively is using certificates. But now you have to get the certificates not just on the device, but we're talking about mobile. It needs to match what both of them are talking to. A pain in the butt. Then let's talk about node versions. And the reason why I bring that up is because a lot of things get installed no matter what language you're doing these things in. A lot of the libraries, unless you're using CMake, gets installed, guess why? Using Node. But the Node version can then affect which security version you have. It's also a pain. API versions also affect how it talks to IoT. And then you have the lack of reuse of code across devices. This is really ugly, and it makes the solutions a lot more difficult. And these things should be really fun. And then you got to play the version game. This is the bad. Which library is supporting for which device? So is the PAHO library for MQTT right up for this one? Well, I know MQTT is right for this one. Or what if I'm using multiple languages? Well, wait, is the build utility available for this version of MQTT? It can be really problematic. And then what about the SDKs? Well, what if I really want to write this in Java? We're at a Java conference. But guess what? Some of the devices that I want to write on, like the MediaTek device, which automatically has things if I want to send signals and talk for telephony purposes, they don't really have a strong Java story, but I want to write in Java. So there's a lot of times that there's not an SDK for the desired language for your mobile or your IoT to match. And then there's features that are unavailable. Well, there's no supports for WebSockets on this one, but wait, this one does have WebSockets, but I need to talk to these various devices. So these are the bad things about building solutions. But there are some good things. The cloud right now is a very positive thing about IoT. And so I would be remiss, I work for AWS, so I'm going to mention the ones that I use the most. So I can now have an IoT SDK for my device that crosses the different languages. So on the actual device, I have Node, C, Python. I can do actually some Go and some Java, but those SDKs are being developed a little bit more than what we have now, so I didn't put them up there. But I can now choose the language that's appropriate, and that's really cool for me. And then I have a mobile IoT SDK that actually knows that I need to talk across various protocols that can deliver that in real time. That usually typically doesn't happen. And so now having that talk in real time and I have callbacks is lovely. And the fact that I can use those SDKs and use the cloud, no matter which one you choose, to now make sure certificates talk back and forth between mobile and the actual device, and so I can be secure, is lovely. And then I can have a shadow delta. And if you don't know what that is, let me explain really quickly. What is the desired state on the device? What does my mobile phone say? They should be in sync. Well, if I click a button and say that I want this desired state to be on versus off, I should know the delta between which of my million devices are now on and that they actually changed immediately and ones that did not. And so I can have API version consistency because now I have these deltas, I have this information, I can update the firmware over the air. Cloud is really making mobile and IoT solutions so much easier and so much better. So this is some of the good things that are coming out. But again, there are some bad and ugly that we're still working through. So what's the really power of the clouds? The power of the cloud is one I kind of skipped, but I won't go back. The fact that I can authenticate, I can do it securely, and I can scale. That's the real power. And I can now go a lot faster despite the bad and the ugly that I have. I can leverage the cloud, go do fast prototyping, but then at the same time scale to billions of devices. That's really difficult to do when you're dealing with something like mobile, IoT, and dare throw AI in the mix. So obviously using the cloud, and again, I'm from AWS, so I'll use the one that I use the most, is I can literally connect a billion devices to AWS, do it from run protocol, do it from run phone, do it from one console, and then I can not only have those billion devices are connected, but they can be connected to you guys via mobile or web, and that interface can be the same, and a lot of that code can be reused. So it really helps me to abstract complex problems into easy use services, all 90 of them, because I know we have a lot. So I am going to show this slide, but then I'm going to go into a demo because I feel like I'm talking a lot and I want to show stuff. And I have 40 minutes, so I'm going to be mindful. So I'm going to skip these and I'm going to come back. So you're going to like, whoa, she went all the way past these, because I am going to show you and hope and pray that my demo works, because again, it is demo time. So let's hope the demo guides will be kind to me and you guys will work with me. All right. So this is where you guys got to interact with me. So here is a mobile application. It is a mobile application that I purposely actually ported to also be a web application, because I know you guys are not going to sit there and download this from your Android to your iOS device. I already knew it. So if you guys would go to that bit.ly, and while you go to the bit.ly, I'm going to bring up the browser. All right, so I have a bunch of things open. Haha. So as you're voting, this is happening in real time as you vote. As you vote, this cube is going to change and I can actually see your voting. And how I'm doing that dynamically through this cube that's actually represented not even physically here, but actually that's being tracked about what you're doing, is using AWS IoT. So this is happening in real time. So for instance, if I go to the same link and vote, you can see that absolutely it is a real. If I could click on my own link. Yes. You don't see my screen. That is problematic. Let me see. I'm glad you said that. Why don't you see my screen? Well, I'm just going to end the slideshow and just go back to regular. All right. Now you see my screen. So I wasn't lying when I said you were voting. Thank you for that catch. All right. So as you vote and do things, actually what I'm doing here with this code is I'm actually sending dynamically this to AWS IoT. AWS IoT is translating each one of these things in real time using the MQTT protocol. I'm using a serverless Lambda function. I'm going to show you the architecture that actually is then kicking off and then talking back and forth from your phone and your interface as you click this back and forth to AWS IoT. And this is happening in real time, as you can see. And this is the power of using AWS IoT or a cloud service for IoT for mobile, because I can immediately get your feedback as you guys click and can control these devices. So this little cube thing that I have while I'm here with you guys is actually sitting in the US, actually responding to this. And this is a virtual I can't talk today. Emulation of it. I cannot talk. Anyway, so that's, again, the power of IoT. Immediate responses. You guys get the scale and you can see things happening in real time. All right, so let's go back to the slides really quickly. And actually, so that you guys can see it. I got a bunch of stuff open. All right, so back to the slides. I'm going to make sure it comes up this time. All right, good. All right, so back to the architecture that empowered that demo you just saw, where I actually have a cube lighting up. Even though I'm here in the UK, that cloud can scale, and the virtual image of that gets projected with the little IoT device I have, you get to see real time and what's actually happening with it. And what enables that is I'm using, obviously, the cloud. So I'm using AWS service for mobile and IoT development. And some key things you'll find with that. The first thing is I'm talking back and forth, or you guys are talking back and forth to that cube, but we're doing it securely. That's what's really great. And we're doing that securely because, again, I'm using for authentication, even though you're unauthenticated, you didn't have to log in or do anything else. I'm using Cognito to ensure that a token gets created. It's temporary, so it's not going to last long, but it has least privilege permissions that then can say, when they click this, I can trigger these services, and triggering these services can then control my IoT device. And you can do that through your mobile phone. And how you can enable that is as follows. So we have mobile app development. We have some options there. If you want to just prototype and get started, you can use Mobile Hub. We have Mobile Hub both for IoT solutions, as well as if you want to build for Android or iOS. So you go there, you do a prototype, it actually downloads the actual real product or project to you, whether it's iOS or Android, and then you can go from there. And you can see the code already written for you that connects to the cloud and or connects to things like AI or IoT. And that is great if you're getting started, but you guys are professional and you're rock stars in coding. So we have SDKs specifically for your language. So whether you're building on Android or iOS, you're doing browser-based or React Native or even .NET, we have that for you. What triggers us serverlessly then is using Lambda. And so you can use Lambda to create that serverless backend, and you saw that immediate response that is triggering from your event that you did to having a response to IoT. The rest of these are just what I call gravy on top of things. So if I wanted to send an email based upon someone walking into the vision, and I'll actually give you my GitHub afterwards because I have that solution actually on there. I want you guys to try it, where you can build a kind of alarm system. Someone comes by, you have a camera there. I have the code for both a big camera and a little small one, that it can actually trigger motion, take a snapshot of the person, send it to your email, as well as immediately come up on your phone or your mobile app. And so kind of difficult to show that here, but that's why the code will be out there for you to see it. So these are things you can do to actually have immediate responses. You can create your own ring if you want to. So with IoT, as I explained, there are multiple scenarios of what you can trigger in real time. So I just want to make sure you know that the best practice that we found, and this is any cloud, and obviously I work for AWS, so I'm saying this cloud, but using the cloud and starting in the cloud is what first scales you. So you can get the messages back and forth using WebSockets or MQTT. You can use authentication and authorization. There's a registry for your devices, so you know what devices you have registered, where they are and what they're doing. And then you can have these actions put in place, whether these actions are in the cloud or they're REST APIs you're using. So this is great about it. But what about those scenarios that I don't have connectivity? That's great, Terry. You're saying all this stuff, but I don't have connectivity. There's a concept we introduced called Greengrass. And Greengrass actually takes all that power of the cloud and doing things dynamically, doing things serverlessly, capturing that real-time interaction and puts it locally on your device. And when you connect back to the cloud, then it will sync all that data back and can update back and forth. So it's okay. You're not connected. You're out in the middle of nowhere. There are millions of devices and millions of pieces of information that, due to being on the edge, will never reach the cloud. And so we want to hopefully fix that by allowing you to have this interaction about at the edge. So again, if you are looking at building IoT solutions at the edge, either being the connection with your mobile device or with just a device, we have Greengrass for that as well. All right, so we have another demo that we're going to hope it works. And this is where we're going to talk about getting into a little bit of mobile as well as IoT with AI. So doing something a little more cool. Okay, cool. I like that you're still voting. All right, so what I'm going to do is I'm actually going to bring up another one for you. That's not the right one. I want to give you the link if I could find it. Okay, well, I will go to my stack I created, and I have it. Can't find it there. There you go. All right, so this link is actually how you would connect if you have a smart home connecting your light bulb. And you can determine the brightness of it and things of that nature. So if you guys would all go to this link for me, we're actually going to do a couple of different things. First of all, I am going to control the light bulb. I'm going to turn it on and off. I'm going to change the brightness, and you guys should immediately see it happening on your phone. So this is also using AWS IoT tied to, you've seen all these smart light bulbs and things of that nature. Well, this is how you actually then have that smart light bulb that you want to talk to. Even though, like I said, I'm here in Belgium, I live in the US, I can talk to these smart light bulbs no matter where I am, and you can use your mobile device to do so. So if you guys will go to this link. Now, so what I can do is things like adjust the brightness. So let's say I want to beef this up to 22%. Well, there's a difference between yours, what you see, and mine. And you shouldn't see the link on yours because you're going to a totally separate, that link is totally separate from me. In fact, if I actually bring up that link, you'll see that, in fact, I will do that, that I am in a different, let me bring it up. I'm in a totally different view than you guys. So I'm going to connect here, and you guys should see it happen there. Now, only thing about my browser, it's caching a bunch. So if I change it there, you guys should see the 32% happening on your end. Are you seeing it? Okay, cool. All right, so that's cool. I can control a device. Well, what about the AI part of this? You want to do interaction. So one thing I talked about Monday when I had my talk was creating bots. But what about voice interaction? It doesn't just have to be a bot. What about Alexa or Alex? You can build actually voice interaction and AI into this. And this is tying this, which is great, to these services that you have using IoT and the mobile. So what you see here is I have Alexa on my phone. You guys, if you have things like this, you probably do. So I've deployed a skill to actually control this light bulb, that what'll happen is when I talk to Alexa, it will talk to Lambda, it will kick off AWS IoT to control this light bulb to turn on and off or change the brightness. Now, the trick is me to say things right so it can understand me and my Southern accent. So let's see. Alexa, make the light bulb 30%. I think my utterance is wrong.
You don't have any smart home devices. To get started, go to the smart home section of the Alexa app.
Yeah, I said that wrong. Let's see. What is the name of my skill? I think it's light bulb. Let me see this. Let's try this. Let's try Alexa, ask light bulb to go 30%. Oops, dropping my phone.
The light bulb currently has a brightness of 0%.
See, my Southern accent. Let's try it again. Alexa, make the light bulb 50%. I know I'm saying these utterances wrong.
You don't have any smart home devices.
Okay, so since I don't know, let's actually show you the code for it, and then I'll say it right. Since I am destroying what I'm supposed to say, let's go to the Alexa dashboard that I actually created this light bulb skill. This is what happens when you don't get sleep. All right, so in building Alexa, you actually build utterances. These are sample utterances of what I want to say. So let me try to actually say something the right way. And by the way, if you've never used Alexa or Alex, you tell the utterances of what it's supposed to say, and then you can test the utterance. So if I say stuff like, let's see, flash light, just to make sure I'm saying my utterances right. Hopefully I have connection. Is it flashing for you guys? Okay, flash complete. Let's see. It's not flashing for me. Why not? Of course it flashes for you guys. Are you guys flashing? Okay, so let's try this again. All right, so I'm going to say it right this time. Let me say it. Okay, so let me try one more time to do this. Alexa, ask light bulb to flash slowly. Are we flashing now? Yay, I said it right. See, this is what happens when you don't remember your own utterances.
Okay, flash complete.
Thank you, finally. I guess you finally you said it right. So I can build a skill to actually not only talk to Alexa and infuse AI with AWS IoT, I can do that in Now Control. So now I have the power of artificial intelligence, IoT, and your mobile phone. And so as you're building these interfaces and you're building these solutions, you want to think of the best way to interface with the people you're writing these school apps for. Trying to think, let's see, I cannot remember what else to say. We'll say one more thing just to make sure. And again, me remembering what I typed is probably good, but I'm going to blame it on jet lag, whether that's true or not. So let's see. So it's flashing, so I can say, let's see. So let's turn it off first. Alexa, ask light bulb to turn the light on. So it should stay on.
Light bulb has been turned on.
All right. So again, and these are the various utterances that I can say. And what's cool about this is I can infuse this not only with Alexa, but also to things like Lex and Polly. So you can have teletype things that can speak back to people where they type the text, type the speech, and control IoT devices. All right. With that, let me go back to my slides. I actually want to show you some, code to actually do these various things. All right. So, okay, I have 25 minutes. All right. Time goes very quick. Okay. So how this works is that was the cube voting. Let's talk about how this works. What I'm doing is first, as I talked about, I'm using Cognito for authentication. Even though you didn't log in, and I'm doing this also for the light bulb, I need a way to securely connect from the mobile to the IoT through the protocols that I'm using with Lambda and things of that nature. I don't want just to leave it to chance and have a Mr. Robot moment. So I'm using Amazon Cognito to do that. And hopefully you guys don't put, even though we see it all the time, your username and password in your code so someone can grab it. Please don't do that. What's great about this is it actually builds those tokens for you and you don't have to do that. Now, after that, I want this to work anywhere. So like I said, I'm from the US, as you can probably tell by my southern accent, and I want this to scale no matter where I am. So we're using CloudFront so that we can reduce that latency there based upon wherever else I am in the world. When I do the cube and I want this cube to interact with where I am in the US or when I'm in the US, or if you guys are still here, guess what? It'll interact and your latency should be little to nothing. So hopefully you saw the very little latency there. Where I'm storing a lot of the information and the resources to graphically display this, and that way I can dynamically change either the mobile application, the web application, and even if you're using some of the things actually on the device, using less and other things, I can store those things in an S3 bucket. And that means I can dynamically trigger different things to happen from that bucket. So if I want to change an image, I can have that image change in that bucket and dynamically you would see it both in your web application or your mobile application. Now, what's happening when you click that color, so whichever color you all were voting and you were doing a great job with it, is triggering AWS IoT. And I'm using the MQTT protocol to do that. So that's almost immediate. It's saying, okay, I got an interaction. And I am saying that device at that point in time, I got to vote to blue or yellow or whatever you chose, trigger that to be written not only back to the device, but I'm actually writing it to a NoSQL database. So then I can actually track things like voting applications. One of my coworkers, Randall, did a great job of creating a blog post about having real-time call centers and using the web to have you vote and get those really dynamic things. So check him out. But DynamoDB is a way I can store that quickly and easily and scale. And then to verify all of that back again, I can use Cognito to make sure it's secure, whether it's on the phone or whether it's on the web that we did today. So let's talk about some key features of the cloud and AWS IoT and why, I'm really doing the IoT and mobile story. First of all, a registry. There is no way, well, you guys may be better than I, but there's no way you can keep up with millions to billions of devices. And at this point, we're at the threshold of having billions of devices. And you probably have a ton in your home that you probably don't even realize. So what the registry does for me is be able to establish an identity for devices and manages that metadata for those devices. And what that allows me to do then is to do over-the-air firmware updates for these devices or groups of devices. devices, which simplifies my ability to build solutions at scale. Then I have a shadow. Obviously, if I'm here and you're there, and a great example of this, my coworker and I were working together a couple of reInvents ago. I'm building the agriculture demo you probably have seen where we were watering plants dynamically. Well, he was in France. I live in the US. But we could dynamically have the status of whether the plant was watered, both on my phone, both to trigger email. And we can do that because there's a concept in AWS IoT for your IoT devices of a shadow. It is a restful state, but it can tell me exactly the thing state. Is it on? Is it off? Has it been watered? Is it light green? Is it yellow? And I can have the delta, everything in between. I pushed my button. I wanted the light to go green, but because there was an error, what you requested was green, what the current status is red, and what the delta between those, what it was just a few minutes ago was yellow. And I can have all that information. So if you think about it, what if a pipe is about to burst or a dam? You want to know the pressure immediately, and you want something to be triggered dynamically to happen. So instead of having human interaction, even though our mobile devices are great, you want immediately that valve of the dam to be turned off and triggered. So I can write rules based upon these shadows that can serviceably trigger the information to the device to turn off or on, and then send the alerts after the action has been done. So shadows are great for that. And then the rules and actions are what drives that. So the rule is if my threshold of the pressure of the dam got past, 80, whatever, I want to trigger that valve to be shut off and trigger someone to say something is wrong or turn another valve on. So again, some of these key features that help you not only scale, but to really make a robust solution is this. So I am not going to get into this because you guys will get the slides. The key of this is we support all the protocols, MQTT, HTTP over WebSockets. We have a pub-sub model, and then it's secure by default. And again, the key, if you take nothing away, is this is how this platform kind of works. You have the device SDK, you have the registry. I talked about that. I want to get into how you program these things because we're at a develop conference. So one of the solutions that has been really interesting is what if I want, and you see this with things like the iRobot and the like. The robot has no concept of the Wi-Fi in your home. And how does it get that concept of the Wi-Fi unless you're using the mobile device? Well, how does it translate your Wi-Fi, the appropriate security of your Wi-Fi to the robot so that it can then function? Well, one way you could do that is over Bluetooth. So you Bluetooth and talk to the device. You probably have, like I have on my watch and other things, where it talks to my mobile device. Well, if I was building this for Android, and this is actually my real code for the solution we did with the dynamic plant watering, where I take a Bluetooth manager and I connect to Bluetooth to my device and write the characteristics. And so when my device picks up the characteristics that I'm actually doing for the IoT device, I can connect to it. This is actually, believe it or not, I literally cut and paste the code for my solution. Now, on the Bluetooth from the AWS IoT device, then I need to be able to accept what it's sending out as it advertises the Bluetooth. So I need to advertise the IoT device, or not me, but the IoT device needs to advertise. And so that my phone, as it's turning on that Bluetooth, can pick up that what's being advertised and connect successfully. And so on my device, then, this is how you actually connect. Now, I'm using Node.js, and I'll tell you why on the device in a minute. You obviously can use C in other languages, but I'll get to why Node.js was my choice for this solution. But again, you see that I'm using the Bleno library. I'm starting to advertise. This is, like I said, actually my real code. Now, what about sending device to AWS? What from the actual device, the IoT device? So I can do a couple of things. The first thing is I need to make sure I set it up and securely. So I need to establish what port I want to send if I'm going to use MQTT, which is my preferred for it. I usually have a root path of where I'm going to dynamically store my certs. And by the way, you can do your certs obviously in advance. You can do it in the console. You can do it with the CLI. But what's also great is I can dynamically connect securely using Cognito and dynamically create a cert, to be downloaded to the device, and that one I can have a rule that I can only happen one time, and it can only happen from certain devices. So I can again make rules to trigger this, but here's the thing: I want that root CA to be on the device as well as the client cert, because again, I need to match that with a public and private key. And then I will give it a name. So this one of these solutions, we did multiple devices. The code that I grabbed for this, since probably won't use it as much anymore, is the Edison. And then IoT provides for you an IoT endpoint of how to talk back and forth securely, and you choose the region. And then once I have that information, that's the preliminary information just setting up, then I can initialize the communication from the device by literally just saying AWS IoT device. You see that I required the IoT device SDK in the previous step. And then I just pass it using a JSON attributes, what my criteria is that I have set up here with my vars. And then after that, I just said device on connect. And then I can trigger other things at that point. Now, what if I want to send data? So I got connected, that's great, I'm on. This is where I want to do stuff. So I can do one or two things here. Here, I'm using actually the MQTT library. So the device on message, when a message comes in, grab that payload. I can actually then take that message and send it out, because you haven't subscribed, and publish it to an MQTT topic at AWS IoT. And I can do this with various things, but what I also can do this with without using MQTT is using what we call a device shadow. So in our solution where we were watering the plant, every time the plant changed, the device shadow would actually send the desired state that it wanted to the Edison. And then, go back, I did it a little too fast. The mobile device, sent the state, the shadow picked it up, it looked at the delta, and then based upon the desired state versus the current state it talked to, then it sent to the AWS IoT, did that kind of fast. So it would turn on the pump. And so I could either have the shadow, which is a different state that says the pump is on, which is 1, and any light bulb that came on, because we had a light bulb that triggered that the pump came on, is now at a certain color stamp or a time stamp, and that can be on. Now, I can have a reported state if I want to constantly, like I talked about the pump, understanding what's the state of my device at all times. So I can look at another shadow that is like a reported state, and then I can have a rule that says, based upon this reported state, do something. Send a mobile device, send a push notification, trigger something to go on and off. And that state can report that it's 1, but what if it should not be 1? Then I can either have that reported state, this is what accepted, this is what's on the device, and do something different with that. Actually, we did this already, so I'm going to skip and talk about actually what is with that really quickly. So this solution I actually changed a little bit just to say how different you can do it. We use MQTT over WebSockets. Still going to AWS IoT, using the IoT shadow. So what is the state of the bulb? Even though, like I said, we're here and the bulb is elsewhere, what is that state? Then I can talk to it with Alexa. You saw the skill that I created. And again, that's securely done with Amazon Cognito. And this telemetry dashboard, again, with the UI, you can build it for web, mobile, and actually physically on the thing as well. So I'm going to skip this a little bit because I want to show you what the SDKs look like and how you interface with them. So for us, in talking about mobile and IoT, there are two main ones I use a lot. The C SDK, because most embedded devices, IoT devices, usually typically have support for C. And what I would do here is using that C device. It actually, again, this is actually real code, very similar to what you saw with JavaScript. I have the MQTT version. I'm going to have a client ID. I have the host URL that's from AWS IoT, and then I'm going to connect. So very similar to what you see. And then I showed you the AWS IoT device SDK for JavaScript. And then I could do various things. So this is just turning it on and doing a pub sub model. This code is actually doing the shadow. So this is, again, a real shadow where I see a desired state is for my LCD to have, let's say I have an LCD light bulb that does red, green, blue. Then I can, RGB light bulb that does red, green, blue. I can say my desired state to create that color that I want for that LED lamp is this. and registered that shadow. So at all period of time, that shadow tells me what the state of it is. For the IoT, when you talk about mobile, and I know this is an eye chart, but bear with me, wanted to let you guys know what it supported. So we had the latest SDK release as far as the final GA. It's not the latest. We've obviously made our revisions. Happened in December 2015. It supports device and apps for iOS and Android. You can add Jira for process improvements if you want to. We support MQTT, HTTP clients. We have the device shadow strategy. We also have, which I skipped over, if you go to AWS Labs, you can see the sample apps. And then finally, I want to talk about open source, because when we first did this and I first created it, I didn't have the code, or I didn't have an IoT device. I had none of that. And I want you to understand the power of doing things with the cloud. You don't have to use any of the SDKs I talked about, any of the solutions. You can use open source things that are out there today. This is also my real code to connect to AWS IoT when I first started this, using the Paho library. So the Paho Eclipse Foundation library, I actually used and created on my actual Android to be able to talk to an IoT device, both with Raspberry Pi, Edison, and a MediaTek, using the Paho open source library. Now, there's a little bit more code involved, but I wanted to let you know that what's great about these solutions is you're not tied down to people forcing you to use anything. The world is your oyster about how you want to code and the method and the solutions you want to use. And this is the code when I changed it when we actually got a mobile IoT SDK. So I won't go through all of this. The last thing I'll show is I showed a lot of Android, but for those of you guys who are working with iOS, obviously we have an iOS SDK, and this is actually the code from this. And one thing I want you to note is I'm not putting a certificate on here. I'm actually creating the dynamic certificate on the phone and using Cognito to secure that communication to create that certificate. So you don't have to do the model of, okay, do I want to download certificates and things of that nature? Just like if you had an iRobot, you don't download certs and they don't know when you're going to activate it. You can do that automatically and as a developer. This also enables me to do this in the browser. So again, the same code is very similar, so I can have interfaces and various things. The final thing I will say about this is I can actually use Cognito in a very least privileged way. And with having the cloud, that means I can say only this bucket can talk to the cloud with my mobile device. Only this section of the bucket can talk. Well, only this section of the bucket for this specific user can talk. Or only this section of the bucket for this particular region can talk. And so you can really get granular about the identity once you guys get an identity back to do that. You can also do this, people who don't like, it's absolutely okay using consoles or SDKs. You can use the command line to a lot of this. So there's access to the AWS IoT with the command line and also the web console. All right, the final thing, I'm going to skip my mobile solutions because I have 7 minutes and 30 seconds. Like I said, it's really hard to go through this talk. But I want to talk about cross-plat. I only have a couple of slides on it. So I said I would come back to why I chose Node for the device. Well, as you can see, like I said, I've been reprimanded by having a bunch of devices here. I have a bunch of devices. And when we talked about the good and bad and ugly, each time I get a different device, the way I program on the BeagleBone versus the Raspberry Pi versus the now defunct Edison is totally different. And I have to totally change gears either with language. I can't reuse code easily. That bothered me. And so the reason why I actually chose Node was because of two libraries that I've really found to be really great in supporting the sensors. Has anyone heard of Johnny 5 and not the movie? Well, maybe I'm just old and I know about the movie, but anyone heard about Johnny 5 JavaScript library? No one. Okay. So it was created by Buku, and it sits atop a library that is a C++ library. And what it enables for you is to be able to write code across all the devices. You have Node, preferably 4.21 or greater, And I can just tell it what board I'm on, so I can pass that in as a command line. And this code would run whether I'm using a Raspberry Pi, whether I'm using a MediaTek, whether I'm using a BeagleBone, Arduino, it doesn't matter. My code can be the same. So I can actually get reuse out of it. So that's what was the choice, why I use on the physical device, use the Node.js library. There's a second library you should know about. It's called Cylon.js. Same thing, it supports while Johnny 5 supports about 50 different hardware devices, Cylon is relatively new, but it is a great library as well. It supports about 35 different hardware and software platforms, and it supports languages like if you're really into Go. They have Go for cross-platform, so you can start doing IoT and robotics development using Go. And again, very similar model. If I want to use this across all the devices, this Hello World, I just require that library, and then I can have this code actually run on the different devices, which is invaluable. So finally, with 5 seconds left, I would do my due diligence as a employee and say we have a bunch of successful case studies on running and building mobile and IoT devices and solutions on AWS. All of that code is out there in AWS Labs, so go and play with it yourself. And we have analytics to do this for you. So if you want to track what things are, it's a no-brainer. You can do it. I can do things like have a bunch of my Raspberry Pis and have a visualization of it. All right. With that, what's next? You guys tell me. I appreciate your attention, and we have 5 minutes left for questions.